next 3 chapters. Okay, this will deal with sine, cosine, and tangent, specifically chapter 5. Chapter 6, we will graph sine, cosine, and tangent on a coordinate grid. It looks like a sound wave. Okay. And then chapter 7, we solve trig equations. Right? So next 3 chapters are all trigonometry. It's my favorite part of the year. I like it a lot more now. So if we're outside, we just discussed the first thing you have to determine for sine, cosine, and tangent is opposite, adjacent, and hypotenuse based on the reference angle. Okay. So when you enter trig, you're going to start to see a lot of Greek letters. That is Greek letter alpha. It's equivalent to our A.
It looks like a fish.
It definitely looks like a fish.
Is there another way to write it?
That's like writing an A in your
written a little bit differently, because I think Miss Magruder writes it.
There's probably a capital A. That's the smaller case.
Yeah.
And she might write the capital. You can also have beta. Okay, we use that quite a bit. So we can call that angle beta if we want to. I'll introduce you to those as we move along. All right, so if alpha is our reference, this side is opposite, adjacent, or hypotenuse? Okay, opposite, adjacent, and then hypotenuse, okay? And then beta?
Opposite. No, that's adjacent.
Adjacent, yeah, but they can change.
What's the name?
And this is still the hypotenuse, right? So based on which angle that you're referencing. Okay with that? Hope so. All right, sine, cosine, and tangent, we abbreviate. Right? Because we like to abbreviate. Okay, can you just get past that and still work with it?
I can't even, do it with it.
You can, just not yet.
So,
So we're working on it. Okay, fantastic. If we do everything, we wouldn't have to learn anything. Okay. All right, these are different ratios of side lengths in a triangle, right triangle. What? Oh, we'll get to that. Okay, so if we're using sine, that is the ratio between the opposite and the hypotenuse. Based on what angle that you're referencing.
The alpha.
Right, in this case. So if we have a triangle with that angle, the opposite divided by the hypotenuse. Given any two of these are all 3 different variables that can change, right? Yeah. Given any 2 of them, you can solve for the other one. That's why sine, cosine, and tangent are very useful. So if you are given, let's say, alpha is 45 degrees and the hypotenuse is 10 meters, if we plug in where appropriate. And we can solve for that missing side length. That's what it can be. This is a calculator problem for us at this point. I'm going to show you how to not use a calculator for this angle. It's called the unit circle. Do you need me to show you how to type that in?
Yes.
Do you want to go get one, practice it?
Also partial.
Would you like to share? Bro, you want to share? That's your fault. Yeah. All of that.
All right, first thing you have to do, because I teach calculus the first 2 periods before you, is you have to make sure we're in degree mode. Okay, so go to your mode screen. I'm in radians. Okay, you need to change, I need to change to degrees, so highlight it and press enter. That's going to be your first check every time you grab one of those. This is probably going to be wrong, unless nobody else uses this. Okay, so now we're in degree mode, and we'll be good. All right? So, sine 45. That's it. When I was your age, we just started having these calculators. It was a magnificent thing because those used to come out of a book. We had a book. The back of our book had a table of all these in it. 45, 46, 47, and it had all these decimals that we had to look at that. So, now, can you solve that equation?
Yeah.
What do? Multiply by?
I don't know.
Yeah, so we get 7.071 equals the size of the opposite.
That just makes the adjacent three.
It makes it what? How do you know that? You okay with that?
Absolutely.
You could make that same calculation with cosine. If this is 45 degrees, which you know that a triangle's angles all add up to 180, right? So you do 180 minus 90 minus 45, 45 degrees. Cosine 45. Okay, because cosine is adjacent over hypotenuse. And so if this is our reference angle, you can identify adjacent and hypotenuse.
It's the same thing.
Yeah.
Is the hypotenuse the centimeter?
Yep. So we have our adjacent side now here, still our hypotenuse, right? And we make the same calculation.
It's the same.
So type cosine 45 in there.
It's the same number.
Same thing.
Why is there cosine and sine when it's the same?
They are just the same in this particular case. does it make sense that if the angles are the same, the sides are gonna be the same? Yeah, this is an isosceles right triangle, that's always gonna be true. Okay, so what's this side? Yeah. So you can automatically assume that now, because you know that's a special right triangle. We'll get into those a little more, but, okay, so there's an option. You could have done either cosine or sine. All right,
What's tangent used for?
let's do a tangent.
Find a hypotenuse.
Tangent is the last, so we've done opposite hypotenuse and adjacent hypotenuse. What's left? Yeah, opposite and adjacent, last two. So these cover all three different possible ratios. Let me give you a little different picture here. That's low. Yes? Yeah, you bet. Sierra? Somebody's here to check you out. All right, so your triangle's oriented just a touch different, but not a big deal. Which side's opposite?
The right.
Let's go ahead and look at this. This is triangle cat.
The 90 degrees.
Which side? Yeah, 18. So if you're going to name a side of a triangle,
18 with the line over it.
18.
you have to connect the dots. 18, right? So this is our opposite. And then what side is adjacent? CA, right? So I say, give me a measurement. Say what?
69 meters.
Okay, for which side? Okay. Can you calculate the adjacent side?
I mean, yeah.
No?
The length of the
Oh, yeah,
adjacent
because
side?
opposite over adjacent.
Okay, tan of
And
30 equals 69 over
You're welcome.
the adjacent side. A lot of times you'll have a variable there. Yeah. Sure about that? Nope. You solve that problem.
it is 39.
Tan 30 is what?
39.
0.577?
No, you don't.
1?
You multiply it over
It's 3.
How do I solve that equation? Multiply what?
By 8.
Okay, good start. Those cancel out. And?
Oh.
Yeah. Now we divide by. So A is 130-ish, anybody?
119.52.
There you go.
19.52.
Right.
And meters.
If you are asked to include units, we will be in meters. Okay. So those are sine, cosine, tangent calculations. Okay, we get this.
Great, just, you just great.
Okay, there are three other trig functions that you've probably never heard of. Secant, cosecant, and cotangent. Have you heard of those?
No.
They're not the opposite. They are the reciprocal.
Right, and so it's like the negative one sine by it, right?
The negative one.
We've been talking about it last year a little bit.
So secant, cosecant, cotangent are the reciprocals of cosine, sine, and tangent. Secant, cosecant, and cotangent. You ever seen this?
Yeah.
Greek letter?
That's theta. Theta.
Theta, yep.
Gosh, I hope.
Okay. That's the most common trigonometry
Doing those from your
Greek letters that we use. It shows up a lot.
Hey, we did the
Yeah, you probably do. Is that right? Okay, secant is a reciprocal of cosine. Theta? Yeah. Basically, or an O would be more appropriate. Or it's not circular, it's oblong. But that's getting into finer detail. You can also think of it as the reciprocal of cosine, hypotenuse over adjacent. Cosine is adjacent over hypotenuse. Cosecant, can you think of what it might be? That would be cotangent. Cotangent is 1 over tan, which is adjacent over opposite. Okay. Cosecant would be 1 over
adjacent over hypotenuse.
sine, which is hypotenuse over opposite. Yeah, so people get kind of confused by the cosecant being with sine. Okay. So you have to remember that sine and cosecant go together. Secant and cosine go together. It's backwards to what you think it would be. If you want to write these shorthand, you can. Secant, cosecant, and cotangent.
Will we see these like that?
What?
Will we see them written like that?
They will be written with the abbreviations. Yeah. Okay. Can you mean? I forgot to do this. Sine, cosine, and tangent. Do you know the acronym to remember it? Yeah. So, yeah. And I didn't write this down earlier. But sounds like you know. You know what Mr. Frank says? Some old hippie.
That's what it is.
Yeah. Some old hippie caught another hippie tripping on acid.
I forgot the little part.
Yeah. Which probably happened quite a bit and then joined the fun, right? So Soka told us how I was taught, that's how I remember it. Like, if you want to expand it, you can. So these can be used the same way as sine, cosine, and tangent. Solving right triangles if you want to. Not necessary most of the time. But there are a few problems that you'll see that are a little different. So, gibberish. Okay, what if cotangent of theta is 10 over 7? What is tangent theta? Yeah, cotangent is 10 over 7. What's tangent?
Isn't it also?
They're reciprocals, so just flip it. Boom. Right. So you can work with sine and cosecant that way as well, or cosine and secant, right? So use the reciprocal idea to switch between the two. What if you're asked, what is sine theta? Because you did it. Okay, how do we get from cotangent to sine? Or tangent to sine, since we know tangent. There's theta, opposite, adjacent. We know sine is opposite over hypotenuse. How do we calculate the hypotenuse? H is Pythagorean theorem.
So it means it's going to be 12 points.
Do you have the answer?
I think it's
12 point something? 149. Yeah. So whatever that is, 12.3.
12.2.
Okay. So yeah, you'll have to use Pythagorean theorem a little bit. But you should be able to transfer between all of those, right? Questions? Okay, tomorrow we're going to do something about special right triangles, and when you get a circle, we'll be doing some active measurements at the school. We'll be getting out a little more than we have been. So, I'm going to give you a couple days to do the work, to practice.
I gave the draft egg was
Yeah, that's for
Your friend said
Why are you going to be gone Friday?
Yeah.
Wrestling, are you here? Or are you gone Friday? You're here? Okay. So, basketball players. Friday. Okay, this is due. You could turn it earlier, or you could turn it later. But Friday's lesson is something that we discuss almost a daily basis in a calculus course. The unit circle. Okay, so we'll be very prudent on Friday about watching the video. There'll be one item that I'll actually ask you to memorize this year will be the unit circle. That's what we're doing Friday. Okay, so be aware of that. All right, just in case you need But that's new Friday, and let me know if you have any questions on it.